happy to get started as well.
Awesome. Okay. Well, welcome everyone. Thank you for joining us this morning. So today, Professor Alark Joshi will be discussing his research on data visualization in mobile devices. So Dr. Joshi received his bachelor's in computer engineering from the University of Pune in India and an MS in CS from the University of Minnesota and a PhD from the University of Maryland, all in computer science, and was a postdoctoral associate at Yale. And prior to joining USF, was actually a professor at Boise State University in Idaho. Dr. Joshi's research focuses on developing and evaluating the ability of novel visualization techniques to communicate information for effective decision fields as diverse as computational fluid dynamics, atmospheric physics, medical imaging, and cell biology. In addition to that, Professor Joshi is also our department's new chair. And I will now turn it over to Professor Joshi to do his presentation. Thank you so much for being here.
Yeah, well, great. Thank you for the introduction, John. I'm really excited to be here and talk about data visualization. Data visualization is my area of research, and so I'm excited to talk about how that has had an impact on mobile devices. As John mentioned, my name is Alark Joshi, and I am the co-director of the Visualization and Graphics Lab with Professor Sophie Engel, and some of you may have had her or at least know who she is. So let's step back a lot and think about what is data visualization. And, this is unfortunately maybe your perception of data visualization, especially from a computer science point of view, where you might say, you know what, I think it's just pie charts and bar charts, and it's not really that important. Or sometimes, as a student, you might think, oh, I have to write an 8-page paper, but I have some empty space here. Let me just fill it up by adding this really big bar chart in there and make it as big as I can. And so it's obviously far from the truth, but I do know that people do trust graphs a lot more than text. But data visualization is a lot more than that. So many a times when you're looking at data, I see data visualization as having 3 clear components. Let's say you are a data scientist or a computer scientist, and your team receives some new data on how people are traversing through a website. Let's say you work at Amazon and you want to know how long it takes for people to buy something. So you have some new data and you want to actually understand the data, and that's the exploration process, where you are maybe making histograms or scatter plots and things like that to just understand the data a little bit, right? So maybe maybe there's a bug in your pipeline, right, from the time when people come to your website all the way till they click checkout. A lot of people get to checkout, but somehow 99% of them don't buy anything, and you're like, wait, that can't be true. And so you might discover something new in your data that then you have an actionable item. And so this loop here, where I say explore, discover, this loop actually continues as long as you want, really. And hopefully you discover something through the use of data visualization where you're learning something about the data. And at some point you might actually find those insights that you're looking for. And now you have to communicate, or you might have to, explain what you found to your, maybe your boss, or maybe people in the community. Maybe you want to write a blog post about why Steph Curry is such a good basketball player, right, compared to all of his competitors. And so you want to use, again, data visualization to communicate your findings, because people understand graphs a lot better than just a wall of text, right? If you just write 7 paragraphs of text, people may not understand it as well as they might if you just have a really good, clear graph to communicate that information. And as Ben Schneiderman of the University of Maryland said, the purpose of visualization is insight. Can I find something new in the data? It's not just creating pretty pictures that you think are beautiful but not very functional. To further drive the point home, I'm going to talk about this data set called the Anscombe's Quartet. This data set was introduced by someone called Francis Anscombe. And I'll talk about the data set in a second, but it's fascinating to think that someone in 1973 made this comment about a computer. He said that a computer should make both calculations and graphs, but both sorts of output should be studied and each will contribute to understanding. And if you think about computer science today, we think about calculations as things that computers are really, really good at, and think about statistics, artificial intelligence, and now machine learning, where all of them kind of work together, and computers are just fantastic at analyzing data. But at the end of the day, human beings are the ones who are driving the analysis, and graphs can actually help us understand more about the calculations, as well as help us drive the process. So let's say you're looking at a really big graph. You might actually say, hey, there's a lot of data in here, but I'm specifically interested in these two individuals in this graph, and I want to know more about them. So anyway, so that's very fascinating that Francis Anscombe made that comment about using both calculations and graphs. Okay, so let's come to this quartet. So this is a really fascinating data set. There are 4 groups of data. You have basically X and Y values. And if you say, okay, X and Y values, that's great. And you can say, okay, let's highlight the minimum and the maximum values in the data set. And you're like, great, I know there is 3.10 and 19.0. That doesn't tell me anything. I'm going to bring out my stats toolbox and apply some statistics. So you look at that, and this is crazy. All of the 4 groups have the same mean X value, same mean Y value, same variation, same correlation, same LM-intercept, and same LMX effect. And that's insane, because you're like, okay, they do not look same at all, but all the 4 groups have this exact same statistical values. And you might be like, oh, this is weird. But then if you just create a very, very simple scatter plot, you can see that the 4 data sets are completely different. And you can see there are very different patterns. In group 3, you can see this outlier here, which is completely changing the statistics. Group 4 has a very different layout compared to group 1 and 2 again. And there's this outlier point far out on the top right, and that's changing the statistics as well. And so what we get out of this is that, just statistics and analysis are not enough. And while this is a very simple example, um, it is very effective in communicating that, visualization is important. And when you visualize your data, you understand the distribution of the data a lot better. Now, and simple visualizations are often enough. You sometimes might just have a simple bar chart or a pie chart, or, a line graph to just understand the data distribution, or, just what kind of values are in your data. And so this is a even funnier example where they actually have the same statistics, but different graphs. So you see that they actually took the Anscombe's Quartet example and took it to another level, where all of these visualizations represent different data sets, as you can see, but they all have the same statistics. And you can learn more about this on this link here from Autodesk Research. Okay, so I hope now I've, excited you about data visualization. And so now we are going to switch a little bit and think about, why do we even care about mobile devices? And, I don't really need to talk a lot about this. Tablets are increasingly popular. There are more than 2 billion devices just sold just last year. The app market is booming. There are like millions and millions of apps. And we are expecting a lot more from our mobile devices today, right? There was this cartoon that actually had a new iPhone, and it says, can you believe it that this thing can actually call people? To the point where there are so many different features in there that, we have started to expect a lot from them. And what that means is that we actually want to do more with it in terms of even data visualization. So maybe you go for an outdoor run, you want to see exactly your heart rate, or maybe the elevation for your run. If you have a Fitbit, then you might say, okay, how did I sleep last night, or how many steps did I get compared to, let's say, my sibling, or my friend who lives in another part of the world, right? You want to compete, but you want to use these mobile visualizations to understand something more, especially with this quantified self movement where people are constantly trying to hack their bodies by sleeping less and eating less, or optimally, and stuff like that. I mean, obviously finances are a big part of mobile data visualization, and you see more and more apps which have visual representations embedded in their apps. And so as the number of apps increase, as we expect a lot more from the devices, there are lots of things out there that allow you to analyze data. um, and obviously the mobile data visualization field hasn't been idle, and there have been some exciting new research in this field, right from this work from CMU, where they basically use more like a naturalistic uh, way to interact with the data. And so you can see here that you can use your fingers to almost filter data, or you can use your fingers and this use select data, or brush different kinds of data elements. Or if you want to arrange the data, like you just said, if you want to arrange the data in a spiral pattern, you can do that, stuff like that. And this is from 2014, so some newer work from Ramik Sadhana, who was at Georgia Tech, shows you how do we use, a complex app that allows data visualization on a tablet. And there are many challenges with this, which we're going to talk about in a later slide. And Langner actually even talked about how do we have multiple devices talking to each other. I mean, many of us have maybe a smartphone and a tablet and maybe a computer and maybe two or three tablets. Like, how do you have all of them and how do you interact with them? And so in this paper, they said, if you're analyzing data, or if you're looking at a data set, in the past, you might have printed out visualizations, but now you could even have multiple devices, and each device could have different aspects of the data that you're looking at. So I'll just play that again. So here you can see how, one of, like, this phone here is being used to see detail in this fairly complex graph of connections between individuals in a social network. And you're basically almost thinking of them as, uh, interactive devices that you can use to understand the data better. And so this is what I was referring to earlier. If, let's say, you're using Excel or Tableau or some other visualization software, you can't just take it and say, okay, let's just port it to a mobile device, because it doesn't work that way. There are many challenges with just porting it naively. Uh, First thing is that, display sizes are significantly smaller. So, even a 10-inch tablet is almost just 21% of the display area of a 23-inch monitor. And honestly, who has a 23-inch monitor anymore? So our monitors on desktops are getting bigger and bigger. And so we are expecting a lot from our mobile devices as well. The input modality is very different, right? Like, there is no right click on a tablet or a phone. There is no hover. I can't just have my mouse pointer hover over a data element and give me the value under a bar chart, for example. And so there are different challenges there. And computational power, right? Like, you don't have a workstation that's just connected to a power cord. You have a device. That device has a fixed amount of battery. And, if your algorithm or if your technique is taking way too much computational power, then that's not great. You have to be considerate about these things. So in terms of goals for designing mobile visualizations that our lab has, the first one is allow for glanceable interpretation of data, right? What does this mean? It means that, if I'm quickly looking at my Fitbit, I should be able to say, okay, I have taken a fixed amount of steps now, a certain amount of steps. How many more do I need to take? On Apple Watches, you have those three rings. It allows you for quickly getting a summary of the data that you care about. Um, Second thing is encourage user interaction through affordances. So an affordance, I just have this picture of a light switch here, right? Even if you have never seen a light switch like this one, like when I came to America for the first time, I had never seen a light switch like this. But when I saw it, I was like, yeah, nobody had to sit down and teach me how to turn on a light switch, because there is only one thing you can do with it. You have to just either push it down or push it up. So that's basically an affordance. And so through user interaction, you have to maybe have some images or maybe have some animations on the mobile device that show users how to interact with the data. Um, because of the fact that you have very little screen space, you can't just show all the data. So if I take your Facebook network, or if I take your any social media network, right? Like you might have 1,000 or 10,000 connections. I cannot show all of the data on a small screen, even if it's a phone or a tablet. And so what you do is you provide enough detail and then provide more on demand. So I might say, here is an individual, here are the family and close friends that they talk to on a frequent basis. But then if you want to see more information, then you can ask for more information, and then that will be either downloaded from a server or analyzed and then shown to the viewer just from the hard disk. And as I mentioned before, there are many unique constraints of mobile devices. And so things like the fat finger problem, right? That's a big problem. There are many users who, I'm sure you've had this problem where if you are trying to do something on a phone and you're just trying to maybe click an X or just select something, you might end up selecting something next to it accidentally. And so there are many unique constraints and that you need to think about. Obviously, as I've mentioned before, smaller screens and limited power are two of the things that one needs to keep in mind. Um, okay, so having set the stage for data visualization and the current state of the art for mobile devices, I'm going to quickly outline my talk here. So um, the goal of this research theme in our lab is understanding effective use of visualization in the context of mobile devices. The first project I'm going to talk about is where we came up with new ways of actually showing users driving directions data for when you're using a GPS. And I'm going to show you some examples from that. The second project I'm going to talk about is how do we look at data that's off screen, right? When you're scrolling data or you pinch and zoom into data, some data that's on the screen kind of goes off screen. How do you still communicate that information to the user? We're going to look at that. Then I'm going to finish my talk by talking about going from mobile visualization, which is where we are, to ubiquitous visualization, where you might just casually see visualizations around you on small screens in a where maybe not you're not where you're not thinking of mobile as just a mobile phone, but you're thinking of mobile maybe as uh, small devices that are around you that are communicating information to you. Like maybe if you're walking by a trash can, it will quickly just have a short summary on top of it that will say how full is it, or when was it last cleaned, or something like that. So just increasing the awareness um, of the citizens. So the first project is called DriveSense, and like I've said before, it's for improved navigation. This project was conducted in collaboration with Nokia Research many years ago now, almost 7 years ago. The idea was one of the problems I've always had is, the GPSs are not very useful today. And I know that we have Google Maps, so it's not like we are buying a new GPS anymore as we used to. But most of us just go from one place to another, and we kind of very rarely use a GPS. But we were thinking also the driving directions still look the same. There isn't any improvement in terms of how driving directions are displayed on the screen. And so we actually used something called an OBD interface that connects to your car and gets information such as what's the current fuel level, what speed are you driving at, maybe what's the tire pressure, and so on. So it gives you like more than 50 different values about your car in real time. So you can easily buy this on Amazon for like 20 or 30 bucks. It connects to your car through one of those USB ports, or even through the cigarette lighter. It's kind of cool. And so we said, well, okay, we have all this information. What is one of the things that you would like to do? So one thing that I've always noticed is that, one of the research themes that I have in general is reducing the amount of detail that you're displaying to the viewer. And so one of the things that you should think about is if you're driving fast, you have very little uh, like cognitive capacity, and it would be great if you could vary the amount of detail that you were showing the viewer when you're driving fast. And so on the left here is a very simple, this was done in the lab, so obviously nobody was driving at 0 miles per hour. But on the left here, we show you that we have very much more detail at low speeds. We give you information about all the avenues and streets and things like that, because you're driving at 0 miles per hour. But if you're driving at 68 miles per hour, which is much faster, then we show you a lot less detail because you're driving fast. All you really need to know is how far am I from this left turn? I don't want to miss this left turn, right? Um, and we can do a lot more with this. So the next thing that we did was, because we have information about your gas tank, we can only show you the gas stations along your route when your fuel levels is less than a quarter of a tank, right? Again, the system has all this information. The system knows where the gas tanks are, where the movie theaters are, where restaurants are, and just showing all the data all the time is very naive and just causes visual clutter. Whereas thinking about when people need to see that information is useful. Similarly to this example, we also had, this didn't use the OBD interface, but we knew what time of day it was. And so around lunch and dinner time, we would show you the nearby restaurants. So then only then you would see the nearby restaurants as you were driving by, in case you wanted to go and eat there, or, maybe you just want donuts from your favorite donut place. Another thing that I've been thinking about a lot was familiarity-based routing. And so we implemented this in this project. Um, like one of the things that I'm always worried about when I'm going to a new place is just the anxiety that I don't want to get lost. I don't want to get, go into a completely different part of the city or another city, and I don't want to get lost there. Not that we do anymore, but still, I don't want to miss my exit or anything like that. And so one solution that we thought of was, what if you could uh, incorporate the familiarity for a user's driving based on their driving patterns? So I might analyze the driving of a user and identify some hotspots. Maybe it's a gym that you go to regularly. Maybe it's your child's daycare, or maybe it's a movie theater, or something along those lines that you go to frequently and you know that very well. So if I have to go to a new destination, I might just get, if I use the shortest path, I might get a list of 15 new instructions. Or I might just say, hey, drive to your gym, and from there, here are 3 new steps that you need to follow. Because you go to the gym fairly regularly, you can probably drive there without any worries. And from there, you just have to take 2 or 3 new steps, right? And so that reduces your anxiety, and it can reduce your cognitive load when you're driving. So you can just be like, okay, I got this. I just have to follow the last 2, 3 steps. Um, and there's even another angle to this, right? The familiar route does not have to be the shortest route. Like, I'm fine with driving another half-mile extra just so I'm not worried about getting lost, or just that I don't have to follow each and every small, take a left here, take a right there, stuff like that. Um, in terms of the system overview, it was fairly integrated with a browser. So we actually had a plugin that worked with Google Chrome, and you could log in. As soon as you logged in, you could type in your destination, and then that information would be sent to your car. And so your phone actually, and your phone would then communicate with a tile server that would identify different amounts of detail and show you only the right amount of detail based on speed. And then in obviously, as the bottom block here shows you, we also incorporated the sensor data to show you the appropriate amount of information based on the context. Um, Here is kind of a collection of all of the different bits of information. So this shows you the interface on the top right here. You might also have the search history and the dashboard. This is what it would look like in your car. Um, and this over here shows you the amount of detail as you're driving around. And this shows you just our interface in the browser. So in terms of future directions, this was not a pun, but it's a good pun. Future directions for this DriveSense project. The first one is we'd like to analyze preference between familiarity-based routing and shortest route. How many people are excited by it, or is it just me? We've had a basic study where we worked with some people in the lab, and most people preferred familiarity-based routing, but that was not a formal user evaluation. We also want to actually, analyze the impact of this reduced cognitive load. So if I'm actually seeing data that I need at the right time, does that make my driving better? Do I feel more relaxed or less anxious when I'm driving? And there are lots more features since we started the project, and I'm curious to see if we can incorporate them into DriveSense. If you're, for example, if you have an electric car, then can we provide the user some information about, okay, based on your current charge and based on where you need to go, maybe this path might be better for you than going on the highway, which is going to drain your battery much quicker. So we can actually give users much more meaningful information. Okay, John, are we taking questions later?
That is totally up to you. If you'd like to start doing questions now, or if you wanted to continue.
I'm perfectly fine with if students want to ask questions or ask questions in the chat. I'm done with the first project, so I'm going to switch to the second project now, and I just want to see if anyone wants to ask questions about DriveSense. Maybe I'll just wait for a minute. If anyone has questions, you can unmute yourself or post your question in the chat, and then we can continue from there. Okay, we'll continue and take questions at the end then. If you have
I have a question.
Yeah, go ahead.
Yeah, do you when you have a concept you want to research, do you usually start with setting up a focus group, or do you start implementing a design and then ask questions?
Yeah, so I think that's a very good question, especially for data visualization. In the last year or two, we've moved even further lower in terms of starting with a sketch on a piece of paper with like crayons, for example, because that helps you iterate quickly and you can say, okay, this design doesn't work very well. This design works a lot better. Where would the user interface be? What would it look like? Things like that. And then we pick the language or the library or the tool that's best for us to do that. And so we are not iterating on actual like D3 prototypes, we are iterating on sketches. And then we go from there to something like D3 or, Altair or Python, other Python libraries. And so from there, we would iterate again to try and fine tune things. But um, that's usually how we've been progressing with that. Does that answer your question?
Yes, thank you.
Thank you. Okay. So the next project, any more questions? I'm in no rush to obviously get through my slides. Okay. So the next project is actually talking about visualizing off-screen data. And this is, I would say, less directly applicable in terms of like, okay, this is like DriveSense. I can see everyone is like, yes, I have many ideas about DriveSense and I really want to, I can see where this works directly. Whereas with off-screen data, it's slightly more abstract in terms of you might be like, okay, I don't see immediately how it works, but I'm going to help you make those connections now. So the first part that I want to talk about is univariate data visualization, right? Like, so if you are looking at just a single variable, let's say you have a bunch of, I don't know, cars and you want to see all of their fuel efficiency, then you might just plot it using a bar chart. Or let's say you have a bunch of NBA players and you want to plot their 3-point percentage or their free throw percentage because you want to know which player in every team is the best free throw shooter, for example. And so visualizing large amounts of data on a small screen is challenging because as you get more and more data, your bar widths get smaller and smaller and smaller. And so we developed a new framework to actually deal with this limited screen space. The goal was to actually think about the fact that people are already interacting with data on their phones or on their tablets using their fingers. And so they use the tactile interface anyway. How can we complement that? How can we give more information to the viewer in terms of context? So in this case, we use something called the focus plus context approach, and I'm going to quickly tell you more about that. So the idea of the focus is that focus specifies the region of interest. So in this example here, you have the bottom panorama actually of a graph, which is a fairly long graph. And this small gray area here specifies the region of interest. I'm interested in this specific area. So as I select this, it quickly then shows me this segment of the data, right? Now, what I'm doing is I'm selecting this focus. This is showing me the area of interest, but then the rest of the data in the bottom panorama is actually the context. It tells me that this little bump here is not just happening once, but it's part of this cyclical process where there is always a bump in the middle of the day and then it goes back down again, always a bump in the middle of the day and goes back down and so on. And so now when I'm looking at the data, I'm like, okay, this bump is not unusual because of the context that this context provides me. So the term is focus plus context, and the context provides context, which is why there's a smiley face there. So we actually came up with 3 new context providing techniques, and I'm going to go through them one at a time now. The first one is called an aggregation-based techniques, and we call it BG1. And as you'll see in the next few slides, BG stands for bar graph. That's why we're very innovative there. The next one is the fisheye-style sharp transition, and I'm going to introduce fisheye as well. And then fisheye-style smooth transition, which is BG3. So we'll see more about this. This work was done with a student, Peter Games, and we actually got the best paper award at the VDA conference when we submitted this paper. So let's look at the aggregation-based context BG1. So let's say here you have a lot of data, fairly big univariate visualization using bar charts, and you have a lot of data that's off screen. Now, traditionally, if you are looking at, let's say, your spending over the last few weeks, or if you're looking at the amount of steps you've taken on your Fitbit, right? So what happens is you scroll the data and that data just goes off screen. So in this case, we are providing the user with some context in these small regions, which is basically the periphery of this plot. And we actually just draw a very thin line to show that, hey, there is data off screen, and this is the value of the data that is off screen, right? And so what happens is, so here I'm showing you here. So these are these thin lines that you might see for these 4 data values that are off screen. And so if you look at this graph down here now, you can actually see that there are quite a few values that are off screen in this region. There's not much between this 20, let's say 20 to 25 region. There's no data values that are off screen. So if I'm looking at the data and trying to make a decision, or I'm like, okay, here is my focus, here is my context on the left and the right, and I don't want to make a decision without finding the highest value, or maybe looking at values in a specific region that's off screen. So here is a short video that shows you how that works. So notice how the data actually goes onto, it's a little fast. So you might notice that the data kind of adds up, shows up in here and then disappears as the user scrolls the. Yeah. As the user scrolls right, you start seeing that these bars, these lines disappear. So this is just the first technique, and I'm going to go over the 4 techniques, 3 plus control, and then I'm going to tell you more about the results of a user study. Okay. So the next technique is called fisheye-style sharp transition, because there is a very sharp transition. There is a region of interest here, and beyond it, we basically just have extremely thin bars that show you the context, right? So the example here will help a little bit. Right, so if you notice here, there's a very sharp drop off. You have a bar that is, so these are all the bars that are in your region of interest, your focus, and the context is basically shown in the form of very thin bars that are basically 1 pixel wide. Okay, and so then the third technique is the fisheye style smooth transition. And for anyone who's used a Mac, you know all about this. You have this dock at the bottom where whatever you are trying to select ends up being the biggest, and that's like again, focus plus context, where you have the region of focus you are interested in, maybe clicking on music, and context is all of the apps in your dock that you may click on, that you know where they are. So this is a screenshot of BG3, where we have the region of what you're most interested in has the highest bar width. And so here you're looking at the average combined SAT scores. And then as you scroll, as you see, there's kind of a smooth transition where you're not just going from a thick bar to like a 1 pixel bar, but there's more of a transition here. And you can see that hopefully in this video. Let's do it again. That went by too fast in the. Yeah, so here you can again see the same idea where the extremes have 1 pixel bars, and the transition kind of helps with providing context. Okay, the last one is actually what's called a control. So this is where we said we want to compare our 3 techniques, BG1, 2, 3, with basically what's out there. Right now you can scroll and zoom, and we implemented that so that we could ask users to perform tasks using all these 4 different techniques, and we analyze their preference and their accuracy using these 4 techniques. Okay, so we also expanded our techniques to bivariate data visualization, which means now you have 2 variables. You have data on the x-axis, you have data on the y-axis, and in this case, we took the same idea with respect to the periphery plots, and we converted in the form into a circle where now whatever you're looking at is your region of focus here, and whatever is off screen is displayed in the form of these um, thin line segments that are radially emerging outwards from the center of the circle. So here in this video, you can see that as the user interacts with the data, I can easily tell that the data is distributed in a manner where there are many more data elements in the top left and the bottom right um, part of my chart, but there aren't any data elements off screen on the bottom left and the top right part of my chart, right? And so this gives you some more context. So you're not just too focused into a specific part of the data, and it gives you an idea of where elements are. Okay, obviously tablets are not circles, and so we compared with a more rounded rectangular layout to maximize the use of screen space. And it's the same data set, so you can see kind of the same distribution of the data as the data goes off screen. There's more data in the top left and bottom right, not so much in the top bottom left and the top right. Okay, a third technique was actually inspired by like an older version of Google Maps, where it would tell you exactly where you are. So this is called user-driven overview plus detail. And here what happens is that on the screen, the user actually gets to zoom in almost like a magnifying lens into a region of the data that they are interested in. And in your bottom right corner here, we show you a schematic that tells you which part of the data you're looking at. Okay, and so it says basically you're looking at this part of the data, but there's a lot more data outside the screen that you probably don't know about, and I'm just giving you context about it. But you might at some point say, that's great, I want to now quickly look at this bottom left part of the screen. So you can tap on this part of the screen, and then that becomes the main part of the screen, and you can change your focus region very quickly. This video will give you some more insight. So as the user zooms in, you can see that the bottom right updates very quickly, and you can see the user interacting with the data. Okay, now once the user has clicked on the overview, you can actually see that they are able to move the focus region to any part of this data that they're interested in, and that would quickly switch between the overview window and the focus window. Okay, SP4 is basically your classic pinch and zoom. This is when you're interacting with a scatter plot on a tablet. What would you see? Data goes off screen, it goes off screen. There's not much we can do. But this is what we wanted to compare with. And so here, I guess, before I continue, what I wanted to point out earlier was that you have all these different visualization techniques, And these could be applied in a variety of different domains, whether you are looking at your fitness data or you're looking at stocks performing differently in the stock market, or whether you're looking at maybe your machine learning models and the performance of different models. So there are different applications for these, and that's why this is more like fundamental work and could be applied in many different ways. Okay, so in terms of user evaluation, one of the things that we do in data visualization is actually compare your techniques with what's already out there. And this is done in a much more formal manner, where you conduct what's called a user study with participants. So you will recruit participants to work with, to actually take a study with you. You pay them a certain amount of money, depends on how long they have to take, how long the study takes. And you are always trying to make sure that you're not just hiring like college students who are age 20 to 22 and all are males or anything. You don't want that. You want as much diversity as possible so that your results are generalizable. And so in this study, we had 22 test participants. We were able to balance the female to male ratio, and we had a range from 18 to 49 in our participants, which was great. In this case, we wanted to measure the accuracy in terms of which technique is better, how long do people take to perform simple tasks using these techniques, and how happy or satisfied were they using these techniques. So here I'm just summarizing all of this in one slide, the findings from this user study, but there's a lot more detail in the paper. So if you're interested, let me know. So bar graph 2 actually ended up being the winner, so to speak, where just for reference, I'm adding a picture of bar graph 2 at the top right here. Bar graph 2 was the one with the sharp transitions. People performed better with bar graph 2, and they were also more satisfied with this. And in terms of scatterplot 3 actually performed the best, along with scatterplot 4, which was our control. So you could say that, the control was actually pretty good, and the techniques at SP1 and SP2 were worse than what's already out there, which is fine. It's part of research, and we found out that our techniques were not that great for the scatterplots. But we also found that people preferred SP3 more than SP4. So even though people were more accurate, they preferred the overview plus detail technique a lot more. Okay, so future directions for this project are explore semantic clustering, which means that how can I use some kind of clustering to show an overview of the data that's not on the screen, and maybe rather than just making these horizontal lines, maybe I come up with a way to cluster all the elements that are relevant into one cluster and show that on the screen. Maybe explore other aggregation techniques, maybe like histograms or violin plots. Box and whisker plots are another example. And another project which we started last year was to explore larger data. Like let's say you have data that's so big that it doesn't fit on your tablet, then can we use some demand-based, tile-based approach to actually preemptively fetch certain tiles of data and only visualize the data that you're interested in on the screen. So the user should have a seamless experience, but behind the scenes, you are prefetching tiles and making sure that the user gets exactly the data they need, even though it doesn't fit on, even though all the data does not fit on the tablet. Okay, so in the interest of time, I'm going to talk about from mobile to ubiquitous. This is something I'm super excited about, and how mobile has got many different possibilities going forward. So one project that came out of University of Calgary was embedded data representations, right? So that example was that where, a lot of the data analysis actually happens on your computer screen, on your desktop. You're sitting in your lab and you're like analyzing data. That's great, but it's not ideal. What if we had something called situated visualization, right? So if you are a store owner and you are walking in an aisle, could we actually figure out which items are being sold more than the other, or right there and then? So in this embedded visualization, the idea is that you might have maybe colored lights, or you might have some translucency that communicates to the shop owner that the parts that are in red maybe are expiring soon, and maybe we should have a sale on them, or maybe parts that are in blue are being sold quickly and we need to restock those quickly. Um, and so embedded visualization definitely has lots of interesting applications in general. Maybe there is an aisle that's just not well lit and people are not going in there, and maybe it's a simple question of just relighting a specific aisle. In terms of responsive visualization, this is something that I'm quite passionate about, is adapting to the capabilities of the device. So maybe if you have developed something that works on a desktop, that just making a pie chart smaller on a tablet may not be a good idea. Maybe people can't even read it very well. So use different visualizations. So in this example, they use this radial layout for the desktop version, but for the phone, which is mostly in portrait mode, they used a different version where you just had two columns and connections between the two columns. Here on the right here, where it says stack vertically, there was this example about the San Francisco's bus program about homeless people. And on the desktop version, they had, this representation, which was more horizontal, but on the mobile representation, it was stacked vertically. So there are many different things you can do, and we are working on a book chapter on responsive visualization. So let us know if you are interested. Situational awareness is huge. So we are not thinking about like just mobile visualization. Maybe you're thinking of mobile devices as data collectors. So you might have heard of Ushahidi, which is used in disasters, where people are uh, re, reporting problems, reporting emergencies through their mobile devices, and then that data is being used to try and send help where it's needed the most. So situational awareness can be higher using mobile devices. You can also imagine it in less disaster situations, where in this photo here from Copenhagen, it just shows you how many people have driven on this street using a bicycle, right? It just tells you that maybe more people, actually more people than you imagine, might be driving a bicycle on this street, and we should be more careful, or maybe you should consider driving a bicycle. And you can imagine mobile visualizations, which we're here now. Again, we are moving from visualizations on a phone to maybe just visualizations that are around you that increase your awareness of the situation or the system. It can be used in evacuations, for example, where different users are given different information to avoid traffic jams and things like that. Another thing that we've been discussing a lot is like data is mobile. So what if you could have personalized visualizations based on your interest? So let's say you go to a museum and maybe you just touch a display with your hand, and it knows that, hey, Alark likes impressionist paintings. Let's show him where the impressionist paintings are in the museum. Or maybe you've seen certain parts of the museum and you haven't seen certain parts, or something along those lines. Or maybe it can even direct you to certain parts of the museum that you may be interested in. Uh, Another thing, that obviously healthcare is a huge place where this already happens to a certain degree, but maybe you could even get more relevant information when you are interacting with data, maybe at your healthcare provider while you're sitting in the waiting room, rather than just seeing random ads. Okay, so this is something that I'm super excited about. Hopefully one day this will happen, where we have many, many small disposable displays where you can order like a stack of 50 displays from Amazon or something like that. And they just show up as visiting card size displays, and you can just put them wherever you want, and you can use them to either provide information or data, or they can be reconfigured to compare different elements. So you can maybe create your own dashboard, so to speak, in your own house when you're trying to analyze data about maybe your health, or maybe the weather or the climate or any of those things. And so um, this could happen soon enough. And then there are many different ways in which I think this is realistically possible, where you might see seamless collaboration, where you are standing in front of a big visualization screen and you are interacting with data on smaller devices, like we saw with Viz tiles, where you're connecting to different, two, three, maybe n number of devices, and using different devices to look at different kind of perspectives of the data. And so lots of interesting potential there. And to summarize, I'm going to say that, designing visualization applications is obviously super challenging, but very timely. I want to see really cool visualizations on mobile devices that are, almost like the next Pokemon Go, but for visualization. And providing these contextually adaptive visualizations is awesome. I think that's where the future is, where you are providing people information about what they need, when they need it, rather than just blasting them with visual clutter. And I think that as we slowly move from mobile visualization to ubiquitous visualization, where we are seeing more and more devices, we are going to see many more visual representations that are just like casual data representations that show you, how much maybe water has been consumed in your city, or how much energy is being consumed by you as compared to your neighbors and stuff like that. And that might be more interesting. Um, I'm going to acknowledge a few people that have worked with me, obviously, at the University of San Francisco, Professor Sophie Engel, who co-directs the Visualization and Graphics Lab with me. And many students I've worked with in the past: Martino, Alejandro, Tony, Gabriel, and Ruben, who's a graduate student now, who's working with me. I'd like to thank the Faculty Development Fund grants that allow this research to continue. In the past, I've worked with a student, Peter, at Boise State, and with Vidya and Frederick when they were at Nokia Research. And with that, I'm happy to answer any questions, and I thank you for your time. If you have any questions you want to ask me over email, that's my email address. And this is our lab website. I encourage you to go to vgl.cs.usfca.edu to look at the projects that we have worked on in the past and we are working on. We're always looking for students who are interested in working as research assistants, either as directed study or as, as research assistants. So if you are interested, feel free to reach out to us. Okay, I'm looking at the chat to monitor some questions. That's right. Thank you, John. If there are any questions, I'm happy to answer them now. We have time, I think a few minutes, maybe, John.
Sure. Yeah.
You can type it in chat if you want, that's fine. Maybe I'll take students to the lab website while everyone is waiting.
Alark, if a student were to be interested in getting involved in your research lab, either as a directed study or as a research assistant, how would you suggest that they go about doing that?
Yeah, so I think that the first thing to do would be to email me and let me know that you're interested. Frequently, we would like students to have taken either the 360 or 560 data visualization class with us so that they are familiar with things and they can contribute. There are many different computer science aspects to data visualization that are challenging. And so having taken the class before helps. And if you haven't taken the class, that's not a deal breaker. If you know some JavaScript, that can also help us quite a bit because a lot of the online data visualization projects require you to know JavaScript quite well. So I would say email is definitely the best way to go for now. Okay, I'm going to just show the website quickly. Can you see my webpage, my screen? Yeah, okay.
Yes.
Yeah, great. And so this website tells you a little bit about our group. You can go to About on the top right, and it tells you all the professors who are involved with it. In the past, we even used to run a data visualization speaker series where we would ask people from the Bay Area to come and give talks at USF. It was widely attended. More than 100, 150 people would show up. But it was a lot of work, and so we've paused that for now. Now we can't even meet in person anyway. So, in terms of research, we have a bunch of different research papers that we've published. So if you are either thinking about going to get your PhD, or if you even want to just differentiate yourself from your peers, or maybe make your resume stand out, you should consider doing some research, because I think like recruiters and managers like to see that you've taken some extra efforts to actually work with professors on research projects. We have a blog which hasn't been updated recently, but there's lots of interesting ideas that we could do there. Yeah, so that's all there is here.
Well, I'll go ahead and I will post the video of this once it is available off on YouTube. And I'll also include your contact information and the lab information, so that way if students do have questions that they were too shy to ask today, they can email you and ask via email.
That sounds fantastic. Thank you very much for the opportunity, and I'll see you soon.
Sounds good. Well, thank you so much, Professor Joshi, and thank you so much for attending today's research seminar, and I hope to see everyone next week, if not sooner.
Okay, bye, thanks.
Thank you.